Okay, so we're going to finish up the first part of 6.1, and then we'll take a look at part 2. Ideally, we'll finish part 2 today. If we don't, we might have a little bit to finish tomorrow, and then the rest of the time tomorrow would be for review. All right, so it says, use the diagram below to find the 6 trig functions of 45 degrees. Well, we talked yesterday about the size triangle and how it would affect the answer to this problem. Does the size of the triangle that you put the 45-degree angle in matter? So that's what we talked about with...
I mean, it doesn't matter for the angle, but...
this. So does the size of the 45, 45, 90 triangle that I draw...
Oh, no, it doesn't.
No, it doesn't affect the values I'm going to get. Okay, if it's a 45-degree angle, whether it's a small triangle or a big triangle, we're going to get the same thing. The only condition when you're labeling the sides in a 45, 45, 90 is it's isosceles, which means you have to label 2 of the sides the same. If you wanted to label these sides like 5 and 5, you could do that, and you'd get the same answers. You just have to label 2 of the sides the same. But I like to use the smallest version of the triangle I can to keep the numbers simple. So to find the 6 trig functions, what's the first thing I need to find here that I'm missing? And I can't really continue until I find this. Yeah? I need the hypotenuse. And if you use Pythagorean theorem to find the hypotenuse, what would you get for your answer? Yeah? All the sides can't be 1, or that would be an equilateral triangle. That hypotenuse has to be the biggest.
Would it be 2?
All right, let's go through it. So, this is C. 1 squared plus 1 squared equals C squared.
So it'd be the square root of 2.
The square root of 2. So unfortunately, we do have a square root in the problem, so we have to be careful if it ends up in the bottom. All right, let's go through our functions. Now, remember, everything is from the perspective of the angle that you want to do the trig functions for. You have 2 45-degree angles. It doesn't matter which one you use. You're going to get the same answers. So let's do everything from the perspective of that one. Just pick one. Okay, what's going to be the sine of 45? Let's start with what's the definition of sine? Remember, second your way. Yeah.
Opposite over hypotenuse.
Opposite over hypotenuse. So what's opposite in this case? Yep.
The 1.
The 1. And what's the hypotenuse?
Square root of 2.
Square root of 2. And hopefully it's starting to become a little bit automatic that we just fix that right away. But what do you get when you fix 1 over the square root of 2? Yep.
1 square root of 2.
Yep. 1 square root of 2 over 2. Keep this other answer though, because that's going to come in handy when we have to flip it, and then the root will already go to the top. Okay. How about the cosine of 45? What's the cosine? Yep.
Same thing.
It's going to be the same thing because the opposite and the adjacent sides are the same. So if they're the same, then the sine and cosine are the same. So square root of 2 over 2. And how about the tangent? Quinn, what's going to be my tangent of 45?
Just 1.
Just 1. It's going to be opposite over adjacent. That's 1 divided by 1, which is just 1. Okay, while we're here at the tangent, let's do the cotangent, because that's the only one that's not a fraction. So it's going to be the easiest one to just get out of the way. Eli, once I have the trig functions on the left, what do I do with them to get the ones on the right? You flip them. So what do we get when we do cotangent?
1.
We get 1. 1 stays the same. Okay, what does CSC stand for again? How do you pronounce that?
Cosecant.
Cosecant. It's the only trig function that doesn't have the first 3 letters as an abbreviation. It uses the first letter of each syllable. Cosecant. Okay. I think we've got enough information to figure out the cosecant without having to do any extra work. The answer is basically right up there. What's my cosecant going to be? Yep. Square root of 2. You could have flipped either one of these two answers. The problem is if you flip the second one, the root goes back to the bottom, then you got to fix it again. So don't flip the second one. Flip the first one. Square root of 2. And how about the secant? Aiden, what's my secant going to be?
Also square root.
Yep, that's also going to be square root of 2 because the sine and cosine are the same. So cosecant and secant are the same. And there are the 6 trig functions for 45 degrees. Any questions on that one? All right. Let's see if we can do the 6 trig functions. I'm not going to do 30 and 60. Let's just do 30. So we need to draw a triangle, a right triangle, that's going to have a 30-degree angle to figure out how to do this. Well, if it's going to have a 30 in it, what other angle is it going to automatically have in it? If it's a right triangle with a 30. Yep.
More than 60 degrees.
Yep, it's going to have a 60. So what we're going to try to do here is draw a 30, 60, 90 right triangle. It has to be drawn to scale. It has to be labeled correctly. So I've given you a hint at how to figure out, because you have to figure out the diagram this time. Not only you got to do the sine and the cosine and all that, but you need to figure out the diagram yourself. My hint is to start with this type of triangle. And what kind of triangle is that? Equilateral. That's not a right triangle, but we need to do something to make it a right triangle. What is each angle in an equilateral triangle? 60. These are all 60. 60, 60, 60. Can somebody think of something I can do to that triangle that would turn it into a 30, 60, 90? I need to add something to it. Yeah? Yeah, put a line going right down the middle. Just like that. Now, just to make it easier, I'm going to take this part right here. I'm going to trace it. I'm just going to move it off to the side. Okay, so we know that's 90. How much is the angle in the lower left? Yep, 60. And then the angle at the top would have to be how much? It has to be 30 because we cut this one in half. Or they all have to add up to 180. Okay, how long is the hypotenuse in that 30, 60, 90 right triangle? Yep. Okay, we know that's 2. Once we know all the sides, then we can figure out the trig functions. We just need all the sides. So we've got a 2. What other side do I know here? Yep.
No, the bottom one.
How much is the bottom one?
1.
1. Because the triangle on the left and on the right are congruent. That means they're copies of each other. Well, if the total length of the bottom side is 2, and this part from here to here is the same as this part from here to here. Two things that are the same and add up to 2 have to each be 1. So we know the bottom side is 1. And now we can get the height. That's the line we just drew. By using what theorem? Yep. Yep, we can do Pythagorean theorem. So we call it A for a minute, but we're gonna replace that with a value. So we've got 2 squared equals 1 squared plus A squared. So 2 squared is 4, 1 squared is 1. Bring the 1 to the other side. And what's the height of that triangle? Yeah. Square root of 3. And you might have known these numbers. These are special numbers that come up when you do a 30, 60, 90. 1, 2, square root of 3. All right, so now we figured out the diagram. That was the hard part. Now we just go through all the trig functions. And we're doing it for the 30. The original question said do it for the 30 and the 60. That'd be 12 different answers. We're just going to do it for the 30. So, Elva, what's my sine of 30 degrees?
It's what's the thing? It's I forgot how to do sine. It's what we want.
Can you help them out? What's sine? Yep.
Do you want me to say the formula or just say what it is?
Just
Opposite over hypotenuse.
Yep. Opposite over hypotenuse.
Then it's 1 over 2.
1 over 2. Here's my sine. Ashley, how about my cosine?
Sorry.
How about my cosine of 30 degrees?
Cosine?
Yes.
I'm not sure, so.
Okay, what's our formula for cosine? Just tell me the formula. Yep.
Adjacent over hypotenuse.
Adjacent over hypotenuse. So what would be my cosine if that's the formula?
That would be 1 over 2.
1 over 2, that's my sine. That's opposite over hypotenuse.
Sorry.
Chris, can you help out?
Yeah. The square root of 3.
1 over the square root of 3. That's opposite over adjacent. I'm going to write that down because that's the tangent. That was going to be my next question. So 1 over the square root of 3, which needs to be fixed. We still need cosine though.
I got that one.
Yep.
Square root of 3 over 2.
Square root of 3 over 2. Adjacent is the side that's next to the angle. Hypotenuse is across from the 90. Okay, so there's your first 3 trig functions. Any questions on those? Right, let's flip them and do the other 3. Don't have a ton of space. Let me just try to move these over. Okay. How about Lucas? What's my cosecant going to be?
2.
2. Just 2 over 1. You could just say 2. Perfect. How about my secant? Anybody tell me what the secant will be? Final answer? All fixed. Yep.
2 square root of 3 over 3.
2 square root of 3 over 3. Good. and my cotangent. Kelly, what's my cotangent going to be? Perfect. Square root of 3 from just flipping the tangent. Okay, so any questions on finding the 6 trig functions for 30 degrees?
Can they all be the same basically with the other?
Yeah, if you did 60, you'd get all the same answers. They'd just be in different spots. Yes. Yep. Okay. So I want to talk about a theorem that's going to come up, and it's going to have to do with complementary angles. So we say that 2 angles are complementary if they add up to 90 degrees. My question is, if you draw a right triangle, why would angles 1 and 2 always be complementary? If you draw a right triangle like that, it doesn't matter how you draw it. I mean, I could have drawn it like, really tall like that. Angles 1 and 2 have to be complementary. How come?
It has to add up to, what is it, 180.
They all have to add up to 180. Okay. I'm not connecting it. So why are angles 1 and 2 complementary? Next.
Those 2 angles have to add up to 90.
Why?
Because the other angle that we know is 90.
Right.
With that makes 180.
So the other angle that we know is already 90. If you take that away from the total of 180, that leaves you with 90 left for the other 2. So angles 1 and 2 have to always be complementary. So here's the diagram that we're generally going to use when we're solving right triangles. Now, our book uses, and you saw it last night, capital letters for the angles, lowercase letters for the sides. I don't like that. The reason I don't like using capital English letters and lowercase English letters is because depending on the letters you pick, they can look the same. Like let's say you picked C, and you use a capital C to represent an angle and a lowercase c to represent the side. Well, I can't really tell the difference between capital C and lowercase c without other letters around it. So, not a good idea. So, we will use lowercase a, b, and c to always represent the sides, but we're going to use alpha to represent one of our angles and beta to represent the other one. So now, if I ask you a question like, how do you figure out b? You know I'm talking about a side. It's not like if I used capitals and lowercases and I said, how do you get b? Then you'd have to ask me, which b? Capital B or lowercase b? So we won't have any confusion with that. You do always have to put alpha opposite A, and you have to put beta opposite B. You can draw the diagram flipped around if you want. Like you could draw it this way, that's fine. And you could put A on the bottom and you could put B on the side. A and B have to be the legs. Doesn't matter which leg is which. But once you put your sides like that, alpha would have to go up there because that's opposite A. And beta would have to go there because that's opposite B. So you always have to keep those opposites. All right, so we're going to look at, doesn't matter which triangle, they're exactly the same. We're going to look at finding a couple trig functions. And I want to show you something that's going to happen with what's called, with complementary angles. All right, let's make up a problem. Sine of alpha. So just like what we did in the notes, except now you don't know what the angle is. You don't know the side. It's going to be all letters. So I'm going to use this angle this time. Using the definition of sine, from the perspective of alpha, what would sine alpha equal? Yep.
A over C.
Yeah, opposite over hypotenuse, A over C. Now, I'm going to make up another problem, but I'm going to make it up a very specific way. I'm going to do two things to this problem to make up a new one. I'm going to take this trig function, and I'm going to put the word co in front of it. If I put the word co in front of that, what trig function do I get? Yeah,
Cosine.
cosine. So put the word co in front of that. And I don't want to use alpha this time. I want to use the angle that is complementary to it. What angle in this diagram did we just say would be complementary to alpha? We don't have a number for it, but
Beta.
beta. Okay, let's do that problem. Cosine beta. Cosine is adjacent over hypotenuse. So from there, what side is adjacent to beta? A. Adjacent over hypotenuse. What side is the hypotenuse? Yep, BC. What do you notice about the sine of alpha and the cosine of beta?
They're the same thing.
They're the same thing. And it's because I made this problem up in a very specific way. I put the word co in front of this, and I took the angle here and found its complement. Sine and cosine are an example of what we call co-functions. There's two more pairs of them. What function do you think would be the co-function of secant? Yeah. Co-secant. Put the word co in front of it. Okay. And there's one more. Tangent. And what function do you think would be the co-function for tangent? Yeah? Cotangent. So these are what we call the three pairs of cofunctions in trig. Sine, cosine, secant, cosecant, tangent, cotangent. Those are called cofunctions. And what happened right here would always happen. If you have two different trig questions, and you look at them, and this function are co-functions of each other, and this angle are complementary to each other, then the answers to both of these problems always comes out the same. And that's called the complementary angle theorem. You have co-functions of complementary angles. The answers always come out the same. So we'll do a couple examples of that, and then that'll finish up the first part of 6.5. As I thought, we're going to start a little bit of the next part of 6.5, but we're going to end up finishing tomorrow. Okay, so let's look at a problem where you would use the complementary angle theorem. It's very short. Cofunctions of complementary angles are equal. That's it. That's the whole thing. All right. Now, this example is set up in a very specific way. You cannot change anything in that example or it won't work. We've got the sine of 35 minus the cosine of 55. 35 and 55 are not nice angles. I have no idea what the sine of 35 is, nor do I know what the cosine of 55 is. But I don't need to know either one of those to do this problem. All I have to do is notice a pattern. I have sine, and I have cosine. What are those called? Sine and cosine. Yep. These are cofunctions. Now look at the angle. We have a 35 and we have a 55. 35 and 55 are what kind of angles? Yeah. These are complementary. So these are cofunctions. These are complementary. What did we just say about cofunctions of complementary angles? When you do the answer out, they both come out equal. They both come out equal. So I don't know what this is, and I don't know what this is, but I know that I'm subtracting two things that are the same. The sine of 35 is the same as the cosine of 55. So what would I get when I do that? Yep.
0.
0. Now, if you change that 35 to a 34, well, now you messed up the whole thing. Can't do it. These had to be cofunctions, and these had to add up to 90. Okay, let's look at this one. Again, 20 and 70, not nice numbers. But you don't need to figure these out to get the answer. Tangent, cotangent. What are those? Yep.
Equals.
Well, tangent and cotangent are
the same. No.
cofunctions. And 20 and 70 are complementary. So we passed, like, both things that had to happen are happening. We have cofunctions of complementary angles. So we are dividing two things. And the value in the top, how does it compare to the value in the bottom? Since these are cofunctions of complementary angles. They're the same. This value is the same as that value. So what would you get for an answer? Yep, 1. So the complementary angle theorem is a very specific theorem that applies when you have that situation. And it makes it very easy to simplify. So in that kind of problem, I'd be more interested in why the answer is 1 than actually you getting the answer of 1. I want you to tell me why. Yeah.
This is a little off topic, but is there a term for angles that add up to 360?
Not that I know of. There's complementary, supplementary. Well, angles that add up to 180. You also can call it a linear pair from geometry. But adding up to 360, no, not that I'm aware of. I'm not saying there isn't, but not that I know. Okay. So last night we did the 1 to 14. We didn't do 16 and 18, right? I think we did 1 to 14 and 21 to 23. So the first part of what I'll have you do tonight will be that. So it's 16, 18, 2 questions from the book, and then 2 questions I want you to simplify based on the complementary angle theorem. What I'll do is I'll copy this, so when I get to the end of the next part, I'll paste it in. All right. So in part 1, we learned about the 6 trig functions and their definitions. In part 2, we're actually going to use that to do something. Do something involving a triangle. And the goal of part 2 is basically to figure out how big all the angles are in a triangle and how long all the sides are. That's part 2. And when you want to find out how big all the angles are, and you want to find out how long all the sides are, that is called solving the triangle. Now, I can't just give you just a blank triangle and say solve it. I have to give you some information to start. Well, first of all, we're solving those kinds of triangles. That's the kind of triangle we're solving. What do you already know about every problem we're going to solve? Yeah?
One angle is going to be 90 degrees, and the two others are going to be 45. Or, actually, that's not entirely true.
No, they don't always have to add up to 45. You could have something like that,
Yeah.
where that's like 80 degrees and that's like 10. They have to add up to 90. But the point is, you're definitely going to have one angle that's 90. Now, in addition to knowing that an angle is 90, I have to tell you two other things for you to be able to solve the problem. I either need to tell you one of the other sides in the triangle and one of the other angles. That's enough information to finish the problem. Or I need to tell you both of the sides. My thinking is we might get through one of these cases today, and we'll probably save the other case for tomorrow. So basically, when you have to solve a triangle, there's 6 things to find. 3 sides, 3 angles. I'm already giving you 3 of the things right away. The 90-degree angle, and then either another angle and a side, or 90-degree angle and 2 sides. So you're going to know 3 things right away. Just a reminder too, what do all the angles in a triangle have to add up to? Yep.
180 degrees.
Yep, 180 degrees. And Pythagorean theorem is the theorem that we're going to use if we know 2 sides and we want to find the third. Now, we learned about 6 trig functions in the first part of the section. Only 3 of those have buttons on the calculator. What are the 3 trig functions you have buttons for? What?
Sine, cosine, tangent.
Sine, cosine, and tangent. Because sine, cosine, and tangent are the only ones that we have buttons for, those are the 3 that we're always going to use to do these problems. Could you use the other 3? Absolutely. But it's going to be more complicated because you don't have a button. So we have to pick one of those 3. How do we know which one to pick? Well, it depends on your problem. You're going to look at the triangle. And you're going to look at what's the information that I was given. What's the information I need to find? Let's say you were given the opposite side, and you're trying to figure out the hypotenuse. So now you need to think in your head, okay, I know the opposite side. I want to get the hypotenuse. What trig function has opposite and hypotenuse in it? It's only one out of these 3. So which trig function we use, we're going to draw a diagram, and then we'll figure it out. So if you're doing a problem with opposite and hypotenuse, you're going to use sine. Adjacent and hypotenuse is cosine. And tangent is opposite and adjacent. All right, let's try this one, and that'll probably be a good place to stop. Okay, so the directions are to solve. And my suggestion when you have to solve a triangle problem, Opposite and adjacent are easiest to figure out if you have a picture. Then you can see, okay, opposite's here, adjacent's here, hypotenuse is up there. All right, so we want to draw a picture. What do we use as the labels for the three sides? Yeah.
Lowercase a, b, and c.
Lowercase a, b, and c. For now. Some of those I'll be able to fill in with the information from the problem. What do we use for the name of the angle that's across from side A? It's a Greek letter. Yep.
Alpha.
Alpha. And the name of the angle that's across from side B? Yep.
Beta.
Beta. Now, let's fill in some of the information we can. One angle measures 37 degrees. Which angle? Alpha or beta? It doesn't matter. They didn't tell you which one it had to be. So if you put it in a different spot than me, you're just going to have A and B switched. But you're still going to get the same, two answers. Thought I didn't start recording here. Okay, so let's, let's just label one of them. I'm going to make it alpha. And it says the hypotenuse is 8. Now that you don't have a choice about. You need to put that right here. And what I'm going to do off to the side is I'm going to make a table. I'm going to put my three sides in one column. I'm going to put my three angles in the other. You don't really need to put anything for the third angle because it's just the right angle. So just write right angle. Okay. In my diagram here, do I know A? You think, right?
No.
No. I don't know A, otherwise I would have had a number in place of it. So I'm going to put a box around it so I remember to find it. Do I know B? Oh. Nope. Okay. Do I know C?
Unit A.
Yep. Let's fill that in. Do we know alpha?
Yes.
Yes. What's alpha?
37.
37, because it's across from A. And B, we don't know. Or beta. Sorry, beta. Well, we can get beta pretty quickly. How can I get beta? Very easily. We don't really have to use anything too fancy here, yeah?
90 minus 37.
Right, we know alpha and beta are complementary. We just said that. So just do 90 minus 37, and you get 53. Okay, so beta's done. Now we have to find A and B. So let's try to find A. I'm going to circle what was given. This and this. And now I'm going to circle what I'm trying to find. That. Now, I could have used the 53 to try to solve for A. But why do you think it's a bad idea to use the 53 compared to using the 37? Either one of them technically would work, but I would use the 37. Yeah?
Because it was actually given to you, and in case your math was off, then it doesn't throw out the whole rest of your problem.
Right. If you use beta and you made a mistake with it, then it's going to mess up other things. So when you're solving for something in a right triangle, don't use anything you calculated to calculate something else. Always go back to what was given. Okay, so that was given, and that's what we want to find. To figure out which trig function we need to use, let's label these two sides. What is the position of side A relative to the 37 degrees? Yep. That's in the opposite position. What position is the side that's 8 units relative to the 37? Yep. That's your hypotenuse. So to solve for A, I need a trig function that has opposite and hypotenuse in the formula. Because opposite is what I don't know, hypotenuse is what I do know. So which trig function has opposite and hypotenuse? Yep. Cosine is adjacent in hypotenuse. So we are going to use cosine, but not for
Sin.
Yep, sine. So we write down sine of 37 equals, and now put opposite over hypotenuse. What side is opposite 37? Yeah. A. And what's the hypotenuse? 8. Now we just have to get A by itself by multiplying both sides by 8. And when you're doing this kind of problem, it is okay to round that off to decimals. That's what they do. 8 sine 37. That's the answer for A. So all the problems in this part are going to be degrees. So let's do 8 sine 37. And that's the answer. 4.815. 4.815. Now, technically, to find B, you could use Pythagorean theorem, because you know 2 out of 3 of the sides. But why do you think I think Pythagorean theorem is not a good idea?
It involves you using something that you calculated.
Yeah, it involves you using something you calculated, and that's not even exact, it's rounded. So we don't want to use this to find B. We'll find B the same way we found A. So we'll pick up with finding B tomorrow. Okay, so let me... Okay, so let me just fix this. Alright, so we got page 361, 1618. And we'll just try one problem from what we just did. 20. Let's try 39. Okay, so that's the homework. I just added one question. 16, 18, 39. And simplify these two. Okay, we went a little bit slower than I thought through this, but that's okay, because tomorrow is just going to be a review day. So we'll finish 6.5 part 2 tomorrow, and I might end up giving you the review guide for homework. I don't know, we'll see.